Throughout your engineering career, students will work with mechanical properties and qualities of various materials. One of the key tasks that an engineer will carry out is being able to measure and quantify materials. Now, there are two types of quantity. Some of the quantities are solid. Okay, they are known as physical. It's actually there. They can be physically seen, they can be felt. However, there are other quantities that are not solid. These are classed as subjective. A solid or a physical quantity can be measured accurately and given a quantity. So we'll do a simple example. You're in a car, it's travelling between Birmingham and Edinburgh, and for part of the way you are the driver, and for part of the way you're the passenger. When you drive the car, you can feel the speed of the car, and that is a physical quantity. As speed is a physical quantity, it can be measured. If you're the passenger in the car, and the car is speeding along, say 180 miles an hour on the motorway, you will experience a feeling of fear or exhilaration. These are not physical quantities. Okay, these are purely subjective, right, and cannot be measured accurately. All physical quantities, whether simple or more complex, should be measurable using various instruments and techniques. There are several. Some physical quantities are easier to measure than others, so you need to know that. Depending on the properties of the quantity, they can be measured to a high degree of accuracy. Now, you gain experience through trial and error. Scientists and engineers have learned that certain physical quantities are fundamental. When we say fundamental, we mean that they are the building blocks and foundations of other quantities. Okay, so for key skills engineers must be able to work with. You need to be able to work with units of measure. You need to be able to work with prefixes. It's a key skill. Okay. We have to work with notations, both scientific and engineering, and we'll discuss those in a bit. And then what actually manages all of these is what we have is an international system of units, or commonly known SI units. So SI units. The word itself, it came from the French word Système International de Unités. My French is not brilliant, so I may have got that wrong. I apologise to any French students. Now, this was introduced in the 1960s. It's been adapted by many countries. Originally, both we and most of the world used to use the imperial measurement system. Now, the imperial measurement system works on inches, feet, yards, miles, okay, furlongs, leagues, etc. A majority of them, I think, were around the number 14. Right, 7 and 14, which is quite difficult to calculate. So what has been brought in is these SI units, which are parts of tens. So even today, 60 years later, we still have some companies that are using machines that are based on this system of measurement. America, bless its cotton socks, is still using the imperial system. However, it's slowly moving towards a metric system. So this SI unit is now universally accepted. A majority of countries throughout the world are using it. What it does, it provides us with a standard set of measurements. For those of you who have studied Unit 2 and Unit 49, manufacturing techniques, etc. with me, throughout those units, we discussed standardization. It's important to business and for manufacturing for parts to be standardized. This is just the mathematical equivalent of it. Instead of having a variety of different types of measurements that nobody can understand, we have one standard set of measurements. It's simple to use and it's simple to calculate as it's based around tens. And finally, America are now slowly but surely beginning to use it. Once the powerhouse of American industry starts to embrace this and use it, the imperial measurement system will basically fade into the background. Now, it's a work-based tip. Learn how to convert between the imperial system of measurement and the SI system of measurement. Knowing how to do that will stand you in good stead. Okay, now the only way that you can get good at these things is to practice. So it's important for students to know that learning maths and science is like learning a new language. That's as simple as it is. Some students will pick up the basics and the concepts extremely quickly. Some people will take slightly longer. Right? However, all students have to do this magic word called practice. And then if you forget to do something, you need to practice. It's as simple as that. Okay, fantastic. Has anybody got any questions? If you have, you can email me, all right, or you can ask me within the class.